Here we go with part 2 of the Honors Chem Mid-Year Review. And again, just as a reminder, I'll not be posting the actual questions on the slides. You have those in your packets or in your book. So I'm just going to be putting up the answers and any other information that you really need to have in order to solve the problem. So here we go. The first question comes from page 181. This is number 15. And these are some molarity questions determining the concentrations of various solutions. So part A, we have 5.623 grams of a substance. That substance has a molar mass of 180 grams, 1 mole per 80 grams. And so if we have 5.623 grams, that comes out to 0.070 moles. And we're going to create 250 milliliters or 0.250 liters. So in terms of moles per liter, we do 0.07 divided by 0.250 and we get 0.28 molar. Part B, we have 184.6 milligrams. You can convert that to grams if you want, just make it 0.1846. Or the alternative is when you calculate the molar mass, you just make it in terms of milligrams, so it would be 242,192 milligrams. So that equals 7.622 times 10 to the negative 4th moles, and that's put into half a liter of solution. So that means we're going to end up with 0.00152 molar. Part C, if we had 0.1025 grams of a compound with a molar mass of 63.546 grams per mole, then we would have approximately 0.001 moles in 1/5 of 1 liter, which means we would have 0.005 molar solution. Number 17 on the same page. We're trying to calculate the concentration of various ions in some solutions. So if we have 0.15 molar calcium chloride, all you have to remember is that when these ionic compounds dissociate, any multiples of ions, like the Cl2, are going to dissociate as well. So you get double the amount for that particular ion or polyatomic ion. So in this case, for the Ca, for the calcium, we would have a concentration equal to the concentration of the solution. And then for the chloride, we would have a concentration that's double the concentration of the solution, so 0.3 molar. For B, 0.26 molar solution of aluminum nitrate. So the aluminum is going to have the same concentration because there's just 1 aluminum per mole. So that's 0.26. The nitrate, though, there are 3 moles of nitrate ion for every mole of solution when it dissociates. So you get 3 times the concentration, or 0.78 moles. In the next one, we have 0.25 molar potassium chromate. And since there's 2 potassiums per mole, the concentration of potassium is twice as much, so 0.5 molar. The chromate, this whole thing, should be Cr2O7, is a polyatomic ion as a unit, so that is going to have the same concentration as the solution because it's not going to dissociate, so 0.25 molar. Finally, on this problem, if we had 2.0 times 10 to the negative 3rd molar aluminum sulfate, then we would have, for the aluminum, the number is going to be double. So it's going to be 0.004 molar. And then for the sulfate, it's going to be triple the concentration, so 0.006 molar. Moving on to number 21, still on page 181 here. This is a question of how much solution we would have if we wanted our solution to contain a specific number of moles or a specific number of grams. So again, the concentration is in moles, not grams. So first thing we have to do is figure out 0.350 grams is how many moles. Well, to do that,